All right, here we're picking up where we left off with page 2 of the 8.1 notes. Here we're looking mainly at special right triangles on the back. All right, so like I said, we got the generalized form for our 30, 60, 90 right triangle and our 45, 45, 90 right triangles. These are what we call our special right triangles. Now, sometimes we kind of have a third one in there, but it's basically just this one turned on its side, maybe looking something like this, or it's emphasizing the 60-degree angle more, or this one's kind of emphasizing the 30-degree angle, but it's the same sides, same angles. Okay, so really it's just these two triangles. Okay, and then we're going to use these special right triangles as kind of shortcuts, and sometimes it's the only way we can do it to find some missing pieces down here. Okay, but before we move on, the general form of these things is very important. Okay, because there's some things that always stay the same. For example, if I want to know what's the sine of 30 degrees in my right triangle, does it matter how big my right triangle is? Does it matter if my sides are 5 root 3, and then 2 times 5 would be 10? Or if it's 17 root 3 and 34, is that going to change what the sine of my angle is? And the answer is no, because no matter what number I plug in for a, well, it's always going to reduce. Sine, for example, is the opposite side over the hypotenuse. So then no matter what I plug in for a, it's going to be whatever a is over 2 times whatever a is, and then the a's are always going to reduce. Give me a 1 here and another 1 there. And I get 1/2. No matter how big my actual triangle is, the sine of 30 degrees is always going to be 1/2. Okay? The cosine of 60 degrees is always going to be 1/2. The cosine of 30 degrees is always going to be root 3 over 2, because again, those a's are always going to cancel. Okay? They're always going to reduce. Okay? Similarly with the 45, 45, 90, these are always going to work out the same. The sine of 45 degrees is always going to be a over a root 2, which reduces to just 1 over root 2. Cosine, same thing, because it's an isosceles triangle. And the tangent is always going to be a over a. It's going to be 1 no matter what number a is. So it doesn't matter how big or small your actual triangle is, it's always going to work out the same. So that's what's really nice about the special right triangles, is it's always the same. Okay? And then what's always the same? What are we always doing? If we're using the special right triangles, zooming in a little bit. Well, first of all, in a 30, 60, 90, if I do not have the short side of my triangle, find the short side first. And then if I want the hypotenuse, just multiply by 2. If I want the long leg, multiply by root 3. Okay, I'm calling it the long leg because across from the 60-degree angle is going to be bigger than across from the 30-degree angle. Okay. If I have the hypotenuse and I want the short leg, divide by 2. If I have the long leg and I want the short leg, divide by root 3, no matter what my numbers are. Okay? The only thing you really don't want to do is go straight from, hypotenuse to long leg or vice versa. How do I go from 2a to a root 3? That's a little more complicated. Go from 2a to a, and then a to a root 3. That's easier. Okay? Another thing to keep in mind, is your long leg always going to have a root 3 in the number? No. Is your hypotenuse always going to have a 2 in the number in front of it? No. Okay? But what is always the same is this side is always root 3 times longer than that side. This side, for example, might be the square root of 2. Well, this is going to be root 2 times root 3, which would be root 6. So anyways, you're not always going to physically see a root 3 here, just like you're not always going to physically see a root 2 here. But, it's just that relationship. This is always root 3 times longer than that. This is always twice as long as that. This is always root 2 times longer than both of these. And these are always the same sides. Okay, so that stuff doesn't change. Okay, so again, with our special right triangles, we're only doing one of 6 things. We're either multiplying by 2, if I have the short leg and I want the hypotenuse, multiply by 2. Or if I have the short leg and I want the long leg, multiply by root 3. Or if I have the hypotenuse and I want the short leg, divide by 2. Or if I have the long leg and I want the short leg, divide by root 3. So it's one of those 4 things for a 60, 90. And if I have a 45, 45, 90, if I have a leg and I want the hypotenuse, multiply by root 2. If I have the hypotenuse and I want a leg, divide by root 2. And that's it. It never changes. So that's all we're going to do on this next section here, is one of those 4 things. All right, so first of all, part A, for example, number 3, we want to find the length of the missing sides. Okay, well, first of all, what type of triangle is it? It's a 45, 45, 90 right triangle. Okay, great. Those are the easier ones because there's only 2 options. Do I have a leg and I want the hypotenuse, or do I have the hypotenuse and I want the leg? Well, I have across from the 45-degree angle is one of my legs, and I want the hypotenuse. Well, how do I go from leg to hypotenuse? How do I go from A to A root 2 every time? I multiply by root 2. Okay, so then multiply that by root 2, I get 8 root 2. And then my other leg is going to be 8, just like the first leg. Okay, and then that's it. Part A is done. Okay, moving on to part B. Okay, now part B is a little bit tougher. This time my hypotenuse is 8. Okay, now don't worry about the number itself, worry about what side you have. First of all, what type of triangle is it? Well, since this is isosceles, these have to be 45-degree angles. So this is a 45, 45, 90 right triangle. I have my hypotenuse, so I want my legs. So how do I go from hypotenuse to leg? How do I go from A root 2 to A? How do I get rid of the root 2? Well, I divide by root 2. So then I want to take my hypotenuse, which is 8, and divide by root 2 to get my 2 legs. What is 8 over root 2? All right, let's see. We just want to simplify that. I can't have a radical in the denominator, so we want to multiply by root 2 over root 2, which gives me 8 root 2 over 2. And then I can reduce that. Divide this by 2, divide that by 2, and we get 4 root 2. Okay, well then both of my legs are 4 root 2. 4 root 2. And yeah, that works because, you know, if I had the leg and I want the hypotenuse, I multiply by root 2. Well, if I multiply this by root 2 times root 2 is 2, times 4 is 8. So yeah, it works. Okay, and that's about as hard as these will get, is when we have to divide by a radical. Okay, all right, let's take a look at part C here. This time I've got a 30, 60, 90 right triangle. Remember, if we don't have the short leg, get that one first. Fortunately, they gave us the short leg. Okay, that's good. And again, just because there's a root 3 here doesn't mean it's the long leg. It's across from the 30. It's the short leg. Okay, so we have the short leg, A. How do we go to the long leg? How do we go from A to A root 3? Well, multiply by root 3 every time, no matter what the numbers are. So then I want to multiply this by root 3. And the long leg is going to be root 3 times root 3, which is 3. Okay? Now ignore that, go back to the short leg. How do I go from the short leg to the hypotenuse? Every time, no matter what, multiply it by 2. So multiply this by 2, and we get the hypotenuse is 2 root 3. And we're done. Okay, so if you know these special right triangles, it makes these problems pretty easy. Again, the worst thing you can do is divide by a radical. These ones we didn't have to. All right, in part D, last one of these here, another 30, 60, 90 right triangle. Okay, great, we know what kind of triangle it is. Now, which side do we have? Well, across from the 60 is my long leg. Don't even worry about the number. I don't care about that number yet. I have the long leg. I want the short leg. How do I go from long leg to short leg? No matter what my numbers are, I always divide by root 3. So we got to take whatever this number is and divide by root 3. Okay, let's see, 9 divided by root 3. Well, I want to simplify that. We'll multiply by root 3 over root 3 to get the radical out of the denominator. And that gives me 9 root 3 over 3. And then I can reduce this and that. And I get 3 root 3. So then my short leg is 3 root 3. Okay? And then now that we got the short leg, now the other part's easy. How do I go from my short leg to my hypotenuse? How do I go from A to 2A every time? Multiply by 2, no matter what my numbers are. So multiply this by 2, and we get 6 root 3. And we're done. Okay, so again, the special right triangles are very nice once you get them memorized. And again, you're only ever doing 6 things. You're either multiplying by root 3 or dividing by root 3, multiplying by 2 or dividing by 2, or for 45, 45, 90 right triangle, multiply or divide by root 2. Just depends on what you're given and what you're looking for. Okay, last 2 here. Fill in the missing information for the following drawings. Each triangle is a special right triangle. Okay. All right, now, first of all, why does it look like this? Why is there this little arc thing here? We'll talk more about this on another day, but this is basically a chunk of the unit circle. Okay, so the unit circle is basically a big circle with the center at the origin of our axis. Okay, and then for now, the only thing we're going to really worry about is for the unit circle, our radius, which is our hypotenuse of our triangle, is always going to have a length of 1. Okay, we'll worry about the rest of the stuff in the unit circle later. We just want to know what's the coordinates of this point on our unit circle. Well, I got to go over a certain amount, that's my x value, and up a certain amount, that's going to be my y value. And then to figure out how far over and up we go, we're going to use our special right triangles. Okay, so let's see here. We got a 30, 60, 90 right triangle. We're given the hypotenuse. Okay, so like I said, we always want to find the short leg first. If I have the hypotenuse and I want the short leg, how do I go from hypotenuse to short leg? How do I go from 2a to a? Divide by 2 every time. So if we divide by 2, 1 divided by 2, I get 1/2. Okay, so 1/2 is going to be my short leg. And then now that I have my short leg, how do I get my long leg? How do I go from short leg to long leg? How do I go from a to a times √3? Every time, multiply by √3. So 1/2 times √3 is √3 over 2. Okay? Now, one other thing you want to pay attention to in the unit circle is, are you moving left or right? In other words, is this a positive x and a positive y or something else? So since this is in quadrant 1 and we're moving to the right and up, yeah, I'm going over positive √3 over 2. And then up 1/2. So they're both positive. If it was in a different quadrant, you might have some parts that are negative. Okay? But then that's it. We use our special right triangles to find these lengths, and then that gives us the coordinates of that point. And then the last one. Similar problem. This time it's a 45, 45, 90 right triangle. Still the radius in our unit circle, in other words, the hypotenuse of our triangle is 1. Okay? And then in a 45, 45, 90 right triangle, how do we find our two legs? Well, if I have the hypotenuse, and I want the leg, how do I go from a √2 to a? How do I get rid of the √2? In other words, what's the opposite of multiplying by √2? Divide by √2. Okay, so then to get my two legs here, I want to take my hypotenuse and divide by √2. And then we'll simplify that by multiplying by √2 over √2. And I get √2 over 2. Also, just a little note, in this unit, sometimes you will be allowed to leave a radical in the denominator, so 1 over √2 would be fine. Okay, but a lot of times we'll want it simplified. Or sometimes either way will work. Okay, since we simplified it, we'll put the simplified version √2 over 2, √2 over 2. And again, we're going right and up, so they're both positive, so the coordinates of this point are √2 over 2 and √2 over 2. All right, so that wraps up the notes. Hopefully the stuff was familiar. It should have mostly been review, and then it'll start to get harder from here.